Now we're going to look at quadratic functions and their graphs. We've been looking at graphs, but we haven't had to do any yet. Graphs of quadratic equations. I've got y equals, if you'll notice, that's standard form. Again, a cannot be 0. In order for me to have a quadratic, I have to have an x squared. The graph of any quadratic equation, y equals ax squared plus bx plus c, where a does not equal 0, is called a parabola. Parabolas are shaped like bowls or inverted bowls, as shown below. If a parabola is concaved up, that's when its a value, the number with your x squared term, is positive, and it opens upward. If it's concave down, the a value is negative, and the parabola opens downward. And it's very quick information that you can get. Now the vertex, or the turning point, this is considered a turning point. The vertex of the parabola is the lowest point, right here, or minimum point on the graph when it opens up, because that is the smallest y value that will be on that whole curve. It's considered the highest point, or maximum point, on the graph when it opens downward, because that's going to be the largest y value I have on this whole curve. The axis of symmetry is a mirror line, dashed lines that goes through, and what's on one side is on the other. It's called the axis of symmetry. Divides the figure in half. X-intercept is the point or points on the graph where the graph crosses the x-axis. Now in the prior videos we saw it cross 2 times. We saw it cross, well actually touch 1 time. We haven't seen it where it didn't cross. Maybe we'll see it this time. The y-intercept, you'll always have a y-intercept. It's the point on the graph where the graph crosses the y-axis. Let me go back again to the x-intercept. Now all of this is terminology you need to know. But the x-intercept, for it to cross the y-axis, y has got to be 0. For my y-intercept, or where the graph crosses the y-axis, x equals 0. So here's the terminology again with 2 examples. My parabola is in blue. Notice this one's concaved up because the a value is positive. So the vertex is right here. Notice the dashed line goes right through the vertex. It's a vertical dashed line. That's my axis of symmetry. The y-intercept is where it hits the y-axis. This only hits the x-intercept once. When it hits once, that's when your discriminant is equal to 0. That's why I only have one answer. It's one solution. Now in this one, my parabola is concave down because my a value was negative. Notice my line of symmetry, or axis of symmetry. I've got 2 x-intercepts, so for me to have 2 x-intercepts, then my discriminant had to be a positive number. Y-intercept is right here. The vertex is a maximum. So I've got another sheet. Graphing quadratic equations. We've seen that before and that. We also know it's called a parabola. This is the first thing you do. It's very quick. Determine if the parabola is concaved up or concave down. And you tell that by the a value. Determine the vertex of the parabola. Notice this is a coordinate point. You find the x coordinate by this formula. Now guys, your quadratic formula so if you sort of like don't look at that, that is the exact same thing to find your x coordinate of the vertex. There is a reason behind it, but just believe me right now. The y coordinate is found by substituting the x coordinate into the parabola's equation and evaluating. So you take your x value, put it back into the equation, and you'll be able to find your y. Find any x-intercepts by replacing y with 0. Solve the resulting quadratic equation, and this is when we use the quadratic formula. When we factored, we can graph it on the calculator and find the x-intercepts that way. Just follow the instructions. The real solutions are the x-intercepts, where you have the number comma 0, because remember, y has to be 0. To find the y-intercept, by replacing x with 0. And this is the easiest, other than finding the concavity, piece of information to find. When x is 0, it takes out that term and that term. All you have left is your constant, y equals c. So the y-intercept is going to be the constant term. Write it in point form. X is 0, y is c. You plot your intercepts in the vertex, and then you connect these points with a smooth curve. I have to sketch. I can't do a real smooth one. So let's follow directions here. In this one, they want us to find the concavity and x-intercepts. So concavity, my a value is 1. So what do you think? Concaved up. Looks like a parabola going up. X-intercepts, for me to find x-intercepts, that's when y is equal to 0. I'm going to try and factor, since this is one of the nice kind. 3, I got 3 and 1, which is what I need. So my x-intercepts, -3, 0, and -1, 0. One more for this video. Find the concavity, concaved. There's my a value, concave down. Or check with your instructor, see what they want you to do. Vertex. I've got a formula for that. X equals -b over 2a. So -4 over 2 times -2. So the x value is 1. I'm supposed to substitute that back in. So y would equal, it'd be with -2, because that would be 1, plus 4, plus 3. That looks like that would be 5. Y-intercept, that's when x is 0. That would be 0, that would be 0, so my constant value is 3. So that's it for this video. Thank you.